Good morning, students. Chapter 7 AC currents. Yes, we have discussed about AC voltage applied to a resistor, AC voltage applied to inductor, AC voltage applied to capacitor, then LCR series DC circuit. What is second order differential equation of charge, and then solution of that equation by phasor method and then analytical method. Okay. Yes. Now we will see new concept, that is resonance. Now what is resonance? Okay, resonance, one word that we have also here. Okay, in 11th chapter number 14 in forced oscillation. What is resonance? Yes, what is resonance? You will clear this now first of all. Okay, see, every object according to its temperature it oscillates with some frequency. Okay, so yes, if we have one object which is oscillating with some frequency, so that frequency is called its natural frequency. That frequency is called its natural frequency. Now if that object is given external force, if that object is given external force, then yes, there is also some frequency. There is also some frequency for that external force. If both frequencies become same, then amplitude becomes maximum. And this phenomenon of becoming amplitude maximum, is called resonance. So yes, in case of forced oscillation, at resonance amplitude becomes maximum, while in case of the circuit, in case of LCR series AC circuit, at resonance first current will become maximum. How? We will see. Here it is. See, for LCR series AC circuit, for LCR series AC circuit, amplitude of current is given by amplitude of current IM is equal to Vm upon under R square plus XL minus XC whole square, or I can write is equal to Vm upon under root R square plus omega L minus 1 upon omega C whole square, because XL is equal to omega L and XC is equal to 1 upon omega C. Clear? Where omega is angular frequency of source. Clear about this? Okay. So now see, for LCR series AC circuit, amplitude of current IM is equal to this equation. From equation it is clear. IM depends on omega. Vm, that is maximum value of voltage. R, resistance. L, inductance. C, capacitance, that is fixed for given components. So yes, as omega varies, amplitude of current also varies. Clear about this? Okay, here if angular frequency omega is varied, amplitude of current IM also varies. Clear about this? And see, if you take different values of omega, you will get different values of IM. So yes, it is one experiment. Okay, you have to take different values of omega, find IM. Take different values of omega, find IM. Then at some particular value of omega, you will find this current maximum. That at some particular value of omega, you will find this current maximum. So at particular value at particular value of omega, that is omega 0, at particular value of omega, that is omega 0, amplitude of current becomes maximum. Amplitude of current becomes maximum. Amplitude of current becomes maximum. Clear? Okay. And such frequency, this one, such frequency, that is omega 0, is called such frequency, that is omega 0, is called resonant frequency. Now how current becomes maximum? See, here it is. At particular value of omega, that is omega 0, amplitude of current becomes maximum. How? To see, at resonance, okay, at resonance means at resonant frequency, okay, value of angular frequency is omega 0. It is such that XL becomes equal to XC. XL is equal to XC. XL means is omega L. Here I will write omega 0 L is equal to this 1 upon omega 0 C, is equal to 1 upon omega 0 C at some particular value of omega. XL and XC, they both becomes same, equal. Clear about this? At some particular value of omega, that is resonant frequency, capacitive inductance and inductive reactance, they both become equal. That is omega 0 is equal to 1 upon omega 0 C. Okay, so yes, it is condition for resonance that you have to remember. Okay, in case of LCR series AC circuit, what is condition for resonance? XL is equal to XC. XL is equal to XC. Is equal to omega 0 L is equal to 1 upon omega 0 C. So I can write omega 0 square 1 upon LC. So therefore, it is omega 0, it is 1 upon under root LC. Okay, and it is called resonant. It is called resonant angular frequency. Resonant angular frequency. And we know that omega is equal to 2 pi f. So therefore, f0 is equal to 1 upon 2 pi 1 upon under root LC is called resonant frequency. Is called resonant frequency. Is called resonant frequency. Clear about this? So yes, what is resonant frequency? Its equation we have to remember. Omega 0 is equal to, it is 1 upon under root LC. F0 is equal to 1 upon 2 pi 1 upon under root LC is called resonant frequency. Clear about this? So see what happens when XL is equal to XC. XL is equal to XC. So this term will become 0. Yes or no? This term will become 0. Then how to write Im? Then yes, Im is equal to, it is Vm upon under root R square plus, here it is 0 square. Simple. Yes or no? So therefore, Im is equal to, it is Vm upon only R. See, impedance of LCR series AC circuit, we know that it is under root R square plus XL minus XC whole square. But at resonant frequency, when XL is equal to XC, impedance becomes only R. So yes, here at resonance, what you have to remember, at resonance, XL is equal to XC. Impedance Z is equal to R, and this impedance is minimum. And therefore, see, R and I, or we can say this Im and impedance, they are inversely proportional to each other. So yes, impedance Z is equal to R is minimum. So therefore, Im is maximum. Im is maximum, and it is Im maximum is equal to Im maximum is equal to it is Vm upon R. Im maximum is equal to it is Vm upon R. So yes, these things you have to remember. At resonance, XL is equal to XC. Impedance Z is equal to R is minimum, and therefore Im becomes maximum, current becomes maximum. And yes, the phenomenon of becoming this amplitude of current maximum is called resonance. Okay. When at particular frequency, amplitude of current becomes maximum. Amplitude of current becomes maximum when at particular frequency amplitude of current becomes maximum. Such phenomenon is called resonance. It is called resonance. Clear about this? So what is resonance? Okay. When current becomes maximum, it is called resonance. When current becomes maximum, it is called resonance. Now, where this resonance circuit is used? See, this resonance circuit is used in tuning circuit. Tuning circuit that is used in radios and TV. How? See. Yes. Antenna receives electromagnetic waves, means signals, from many broadcasting systems. Okay. So that antenna behaves as source for many signals of different frequencies. But if we want to set only one channel at some particular frequency, then in tuning circuit there is capacitor, inductor, or combination of them. We have to change value of capacitor. So if we change value of capacitor, so obviously according to this equation, omega 0 is equal to 1 upon √L. LC. If we change value of capacitance, value of frequency changes. If this resonant frequency, if in tuning circuit, this resonant frequency becomes equal to, or it becomes near to frequency of that given channel, then that channel is set. Clear about this? So yes, it is used in tuning circuit. Clear about this? Okay, so yes, it is about resonance. Now, at last we have to draw one graph. See, here it is. Now we will draw. See, I say omega changes, then current Im also changes. So what is variation of Im versus omega? See, omega, and here it is Im. If we take different values of omega, then we will get different values of Im. Yes, you know that. So okay, that graph is like this. For one resistor, say R1. Okay. For another resistor, this graph is like this. For another resistor, this graph is like this. Okay. So it is graph of Im versus omega. This graph is for Im versus omega. See, when omega is equal to omega 0, you can write only omega 0. That at that omega 0, that is at resonant frequency, amplitude of current becomes maximum. Clear about this? So yes, it is graph of Im versus omega for two different resistors. Clear about this? At some particular value of omega, amplitude of current becomes maximum. So yes, amplitude of current is maximum. So power dissipated in circuit is also maximum. Clear about this? So yes, it is all about resonance. Okay. Now next question is sharpness of resonance. Yes, resonance. What is resonance? Again, for LCR series AC circuit, for LCR series AC circuit, amplitude of current, amplitude of current IM is equal to Vm upon under root R square plus XL minus XE whole square. Okay, but when omega is equal to omega 0, that is resonant frequency, that is resonant frequency, resonant frequency. Okay, this Im becomes Im maximum and is equal to it is Vm upon R, because when omega is equal to omega 0, we know that XL is equal to XL. Clear? So yes, at frequency omega 0, we will have value of current, that is maximum. Okay, now I will draw this graph again, that is Im versus R, that is Im versus omega, Im versus omega. Okay, so it is Im versus omega, and it is graph for one given circuit. Okay, so yes, for this value of omega 0, that is angular frequency, this current is Im maximum. This current is Im maximum. Okay, so yes, this amplitude of current is maximum at only one frequency, that is omega 0. At only one frequency, that is omega 0. Okay, the Im is maximum at only one frequency, that is omega 0. Okay, this graph of Im versus omega is called resonance curve. Im versus omega graph is called resonance curve. Is called resonance curve. Okay, is called resonance. Okay, now we know that whenever current is maximum, also power is maximum. Yes or no? If current is maximum, we know that power is also maximum. So at resonant frequency, as Im is maximum, power dissipated is also maximum. Power dissipated is also maximum. And yes, you know about that. Now, if I am taking value of current Im maximum upon root 2, for example here, it is Im maximum upon root 2. Then for this value of current, see, if Im is equal to maximum, then power is maximum. But when current is Im maximum upon root 2, power will be half, because P is proportional to I square. So as P is proportional to I square, when current is Im maximum upon root 2, power in circuit becomes half. Clear about this? Yes, when current is Im maximum upon root 2, power in circuit becomes half. Any doubt about this? Okay, yes, it is easy to understand, because we know that P is proportional to I square. So yes, whenever current is Im maximum upon root 2, power in the circuit will become half. Okay, and see, yes, when this current is Im maximum upon root 2, this Im maximum upon root 2 current is possible for two different different values of omega, that it is omega 1 and it is omega 2. See, yes, Im maximum is possible at only one frequency, that is omega 0, but Im maximum upon root 2 is possible for two different values of angular frequency, that is omega 1 and omega. Clear? So yes, that point you have to write. K Im maximum upon root 2 is obtained for two values of angular frequency, that is for two values of angular frequency, that is omega 1 and omega 2, that is omega 1 and omega 2. Now omega 0, omega 1, omega 2. If I say it is delta omega and it is also delta omega, then I can write omega 1 is equal to omega 0 plus delta omega, and omega 2 is equal to omega 0 minus delta omega. Clear about this? Minus delta omega. Okay, so yes, Im maximum upon root 2 is obtained for two values of angular frequency, that is omega 1 and omega 2, omega 1 and omega 2, and we have assumed omega 1 is equal to omega 0 plus delta omega, omega 2 is equal to omega 0 minus delta omega, and if I am taking the difference, that is omega 1 minus omega 2, so omega 1 minus omega 2, it will become 2 delta omega. It is called 2 delta omega, and it is called half power bandwidth. Is called half power bandwidth. Why it is named half power? See, it is called half power because at frequencies omega 1 and omega 2, current will be Im maximum upon root 2, and for current Im maximum upon root 2, power will be half. So that's why this difference is called half power bandwidth. This difference is called half power bandwidth. Clear about this? So yes, omega 1 minus omega 2 is equal to 2 delta omega is called half power bandwidth. Is called half power bandwidth. Clear about this? Okay, so yes, these points you have to remember. Okay, what is resonance curve? At which value of current power will become half for two different frequencies. Clear up to this? Okay, now what is meaning of sharpness of resonance? Sharpness, so for that sharpness we have to obtain one equation of Q factor. What is Q factor? That we will see. Okay, now yes, omega 1 minus omega 2 is equal to 2 delta omega is called half power bandwidth. Now the quantity omega 0 upon 2 delta omega, omega 0 upon 2 delta omega, omega 0 means resonant frequency, okay, divided by 2 delta omega means half power bandwidth, is called Q factor, or quality factor, which measures sharpness of resonance. Hear about this? See from figure. If this delta omega is less, then yes, half power bandwidth is less, and if half power bandwidth is less, the sharpness is more. Clear about this? So yes, that point you have to remember. So now next question is, what is next question? Yes, next question is, you have to obtain equation of Q factor. Okay, so now we will obtain equation of Q factor. How to obtain? Omega 0, you know. Yes, you have to find value of 2 delta omega. You have to find value of 2 delta omega. So how to obtain value of Q factor, that we will see now. Okay. See, for LCR series AC circuit, amplitude of current IM is equal to Vm upon under root R square plus omega L minus 1 upon omega C whole square. Now we have to obtain value of Q factor, equation of Q factor. Now we know that when omega is equal to omega 1 or omega 2, at that time Im is equal to Im maximum upon root. Yes or no? Yes or no? Yes it is. Okay. When omega is equal to omega 1, Im is equal to Im maximum upon. Okay. So yes, here it is. In this equation, we have to compare this Im is replaced by Im maximum upon root is equal to Vm divided by under root R square plus omega L minus 1 upon omega C. Now we also know that Im maximum is equal to Vm upon R. Im maximum is equal to Vm upon R. Yes or no? Im maximum is equal to Vm upon R. So is equal to Vm upon under root. Yes, here you have to replace this omega by omega. Okay. When omega is equal to omega 1, Im becomes Im maximum upon root. So it is R square plus omega 1L minus 1 upon omega 1C. Now we have to compare this two equations. See, Vm upon this is equal to Vm upon this. So yes, I can compare under root R square plus omega 1L minus 1 upon omega 1C whole square is equal to, this side it is root 2R. Now take square on both sides. Take square on both sides. So if you take square on both sides, you will get R square plus omega 1L minus 1 upon omega 1C is equal to, it is 2 R square. Is equal to, it is 2 R square. Yes, here it is square, here it is square. Any doubt? Okay. So therefore, if you take this in opposite side, then it will become omega 1L minus 1 upon omega 1C whole square is equal to, it is R square. Now again take square root on both sides. So therefore, omega 1L minus 1 upon omega 1C is equal to R. Omega 1L minus 1 upon omega 1C is equal to R. Now put value of omega 1. What is value of omega 1? It is omega 0 plus delta omega L minus 1 upon omega when means omega 0 plus delta omega C is equal to, here it is equal to, here it is. Clear about this? Okay. Now take omega 0 common. So here how to write? Omega 0 common. L it is outside, and here it will become 1 plus delta omega upon omega 0. Simple? Okay? Minus 1 upon, if you take omega 0 common in this denominator, then it is 1 upon omega 0 C. Here it is 1 plus delta omega upon omega 0 is equal to, it is R. Any doubt? Okay, so therefore this omega 0 L means it is XL. This omega 0 L means it is XL. Yes or no? Omega 0 L means it is XL. But you can write this term as it is if you don't mind. Okay, omega 0 L is equal to, it is XL, and 1 upon omega 0 C is 1 plus delta omega upon omega 0. Okay, so yes. Here, now how to simplify this term? That is omega 0 L for C. Omega 0 L 1 plus delta omega upon omega 0 minus
upon omega 0 c minus 1 upon omega 0 c. I can write this term in numerical, that is 1 plus delta omega upon omega 0 raised to minus 1 is equal to r. Raised to minus 1 is equal to r. Yes or no? Yes. Now we know one relation. Which relation? Okay, at resonance, XL is equal to XC. XL is equal to XC means omega 0 L is equal to 1 upon omega 0 c. Is equal to 1 upon omega 0 c. Omega 0 L is equal to 1 upon omega 0 c. So here I can replace this 1 upon omega 0 c by omega 0 L. And this equation reduces to, when this equation reduces to c, therefore it is omega 0 L 1 plus delta omega upon omega 0 minus this 1 upon omega 0 c. I can write omega 0 L. And now about this term 1 plus delta omega upon omega 0, I can write 1 minus delta omega upon omega 0 is equal to, here it is r. Why? Because yes, it is binomial expansion, and we know that delta omega it is less than omega 0. So yes, here delta omega is less than omega 0. So therefore 1 plus delta omega upon omega 0 raised to minus 1 is equal to, I can write 1 minus delta omega upon omega 0. Yes, you know this step. Yes, you know this step. Okay, binomial expansion that I have. Okay, clear about this? So now you have to simplify this. See, therefore here it is omega 0 L plus omega 0 L delta omega upon omega 0 and out minus omega 0 L minus will become plus omega 0 L delta omega upon omega 0 is equal to r. So this term cancel out. Omega 0 cut, omega 0 cut, omega 0 cut, omega 0 cut, that is 2 delta omega L is equal to, it is r. So therefore 2 delta omega is equal to r upon L, means half power bandwidth is equal to r upon L. Half power bandwidth is equal to, it is r. Okay, again I will explain this term, that is omega 0 L 1 plus delta omega upon omega 0 minus 1 upon omega 0 c. This 1 upon omega 0 c is replaced by omega 0 L. Okay, and how to write this term? That is 1 plus delta omega upon omega 0 raised to minus 1. Minus 1 power you have to multiply to second term. That is 1 minus delta omega upon omega 0. Here it is. Now open bracket. Omega 0 L, omega 0 L cut. 2 delta omega L is equal to, it is r, and 2 delta omega is equal to, it is r upon L, and 2 delta omega is called half power bandwidth. It is called half power bandwidth, and half power bandwidth is equal to, it is r upon L. So now what is Q factor? Yes, what is Q factor? Yes, Q factor, that is equal to omega 0 upon 2 delta omega. Omega 0 upon 2 delta omega. Yes, you have to obtain equation of omega 0 upon 2 delta omega. Omega 0, it is 1 upon under root L c, and 2 delta omega. 2 delta omega means r upon L. So yes, it is r upon L. So it is L, here is root L, then just Q factor Q is equal to, it is Q factor Q is equal to, it is 1 upon r under root L upon c. It is equation of Q factor. Clear about this? What about sharpness? What is relation for sharpness? See, Q factor 2 delta omega. If half power bandwidth, that is 2 delta omega is less than sharpness of curve, is Clear about this? So yes, it is equation of Q factor. Q is equal to 1 upon R and L upon C. By varying value of C, you can achieve one particular quality factor at which tuning occurs. Clear about this? So yes, it is the whole theory for resonance. Okay, for today, this is it.